Happy Thursday. As a reminder, your test 6 is due tomorrow. As another reminder, the final exam is going to open up on Monday, December 13th. So you're used to your tests going Friday to Friday. But I just want to let you know, because final exams have to be given during finals week. The final exam doesn't open up until December 13th. So you have Monday through Friday of finals week to take the final exam, and the final exam will be comprehensive. So it's going to cover everything in the course from the very beginning until the very end. Anything is fair game. As I had stated in an earlier lecture this week, I will be putting up a optional review assignment that'll have problems from the entire semester for you to practice. It won't be worth any credit, no extra credit, no mandatory credit, nothing like that. It's just for your own well-being, your own studying. But that'll be up soon at some point, whenever, by the end of the weekend. It'll be up by the end of the weekend. It has to be up by the end of the weekend. So look out for that. Okay. I will be taking a number between 1 and 16, the first number I see. Number between 1 and 16. And I can't start lecture without it, so I'm just going to wait here. All you have to do is put a little tippity tap on the keyboard, type in a number, push enter. 7 it is. Lucky number 7. You know what, actually, I'm going to do it this way. I'll put number 7 on this pad. We'll do number. There we go. Ooh, actually, I really like that one. Okay. So yesterday, we talked about 2x2 systems. We talked about systems with 2 equations and 2 variables. Today, we're going to talk about systems with 3 equations and 3 variables. This is probably not surprising, but these are a little bit more difficult. Oh, wait, did I not? Hold on. Give me 1 sec. Let me stop sharing for just a sec. I forgot to send myself my notes. Go back here. Got it. Share content, screen, start broadcast. There we go. Wait, what? Oh, perfect. Okay. So today we're talking about 3x3 systems, 3x3 linear systems. They're a little bit more difficult than the 2x2 systems, but I have a strategy, and it'll be okay. We will all be okay. There are only 6 questions on your homework for this. This is part 3 of your homework, and there are only 6 questions, so you don't have to do too much, just a little bit. So once again, a 3x3 system, there are 3 equations, there are 3 variables, and the answer is no longer a coordinate point, it's an ordered triple. So normally we say ordered pair for x and y. This like x comma y, this is an ordered pair. But a answer to a 3x3 system, since there are 3 variables, is a ordered triple. So their answer is, it looks like a coordinate point, but there's 3 different numbers. There's an x, a y, and a z. Technically, this could exist in a 3D plane. So this could be an answer not in the rectangular coordinate system, but in the 3-dimensional rectangular coordinate system. It's not really rectangular at that point, but it could exist in 3 dimensions. But we're not going to get that far. We're not going to talk about the 3-dimensional space. That's not for here. That's not for now. All we're going to be doing is solving these systems, finding values that make systems like this work for every single equation. So first of all, determining whether or not a ordered triple is a solution to a system, it's the same exact process as we did with the 2x2 system. You take the values, you plug them into every single equation, you make sure it comes out okay, and then you move on with your day. So for instance, with this first one, here we're going to have x equal to -2. y equal to -6, and z equal to 3. And we're going to plug those values in for every single equation. So we have 5x minus y plus 3z equal to -7. So we have 5 times -2 minus y is -6 plus 3 times z is 3 equals -7. That's -10 plus 6 plus 9 equal to -7. And -10 plus 6 is -4. -4 plus 9 is going to be 5. That's going to be 5 equals -7. And that's false. So it fails the first equation. We plugged it into the first equation and it didn't work. So the point -2, -6, 3 is not a solution. We don't even have to plug it into any of the others. As soon as it doesn't work, we are good to just call it a day. Let's look at this one down here. So x equal to -1, y equal to 2, z equal to 0. Again, plugging it into this first equation to start with. So we have 5 times -1 minus 2 plus 3 times 0 equal to -7. That'll be -5 minus 2 equal to -7. And that one works. All right. So one down, one down. Let's try the next equation. We have 3x plus 4y minus z equal to 5. And we are plugging in -1, 2, and 0 for x, y, and z, respectively. So we have 3 times -1 plus 4 times 2 minus 0 equal to 5. -3 plus 8 equals 5. And indeed, 5 is equal to 5. Finally, we're going to plug into that very last equation. 9x plus 5y plus 7z equals 1. 9x plus 5y plus 7z equal to 1. So we have 9 times -1 plus 5 times 2 plus 7 times 0 equal to 1. So -9 plus 10 equals 1. Indeed, 1 is equal to 1. And now that we plugged it into every single equation, every one of them, and it works for every single one, at that point in time, and that point in time only, are we able to say -1, 2, and 0 is a solution to the system. Are there any questions on that part of things? The first two questions on your, I think it's the first two questions on part 3 are just simply asking, like, is this or is this not a solution? Let's see if I can lower this chair a little bit. Where is the oh, there we go. All right, so I'm taking it that sounds a-okay. And if it does, then we're good to talk about solving these systems. How in the world do we even come to an answer using these systems? All right. There's a bunch of methods out there. I really don't suggest trying to look online for a better method. They're going to give you methods that are very confusing if you look online, and they're probably going to introduce something called matrices. And we're not going to talk about matrices in this class. But this is the easiest method that I can give you for solving these 3x3 systems, because it's not as straightforward as the 2x2 system case. So first of all, when we have three equations, it makes it a little easier if we name them. So this guy's, I'm going to call him E sub 1, E sub 2, E sub 3. So that stands for equation 1, equation 2, and equation 3. I'm just going to name them equation 1, equation 2, and equation 3. Your first step is choosing an equation to be your eliminator. And you're going to remove one of the variables by elimination. And this will leave you with a baby 2x2 system that you're able to solve using the 2x2 system methods. As a tip, choose an equation that has a variable with a coefficient of 1 or -1 for your eliminator. So if I'm like looking up here, there's like a few choices of variables that have a coefficient of 1 or -1. So we could either use equation 1 and eliminate the z's from equation 2 and 3, or we can use equation 2 and eliminate the y's from equation 1 and equation 3. Those are the options. Either we're using equation 1 to eliminate z's, or we use equation 2 to eliminate y's. And we're doing that because these guys have a coefficient of 1, and all of the systems that we gave you on MyLab should have at least one equation who has a coefficient of 1 for one of the variables. I'm going to choose equation 1 to be our eliminator equation. So I'm going to highlight him. So this is going to be our eliminator equation. We're going to get rid of z's. We're going to choose E1 to be our eliminator, and we're going to get rid of z's. That means that you need to pair E1 up with both E2 and E3 separately and get rid of the z's using elimination. So E1 and E2. E1 is 3x minus 2y plus z equal to 2. And E2 is 5x plus y minus 2z equal to 1. If we're trying to eliminate the z's, by multiplying one of these equations by something, we would want to multiply this first equation by 2 to make this into a 2z, so that when we add straight down, the z's cancel out. Make into 2z. Using pink this time. So we're going to multiply this top equation by 2. We're multiplying everything by 2. Every single one of these 4 by 2. So 3x times 2 is 6x. Negative 2y times 2 is negative 4y. Z times 2 is 2z. And 2 times 2 is 4. This allows us to leave the bottom equation completely alone. And then we can add them together, just like we did with elimination yesterday. And you'll notice that those z's will indeed cancel out. So 6x plus 5x is 11x. Negative 4y plus y is negative 3y. the z's cancel, and this is equal to 5. I am going to highlight this equation because we are going to come back to him and put him in our baby system. Because notice that that equation now only has x's and y's in it. So now we're going to do E1 and E3. We are using E1 each time because E1 is our eliminator equation. So E1 is 3x minus 2y plus z equal to 2, and E3 is 4x minus 3y plus 3z equal to 7. Again, we're trying to eliminate the z's. So what do we need to make this z into in order to eliminate? What does that z need to become? Make sure you're thinking about whether, there it is. There it is, Brooke. I didn't even have to say the rest of my sentence. We need to make it into negative 3z. Make into negative 3z. So we multiply by negative 3. Negative 3 times 3x is negative 9x. Negative 2y times negative 3 is positive 6y. And z times negative 3 is negative 3z. 2 times negative 3 is negative 6. This equation here. Can I be a cheater, pumpkin eater? Yes, I can. Yes, I can, and yes, I will. All right, adding these two equations. Negative 9x plus 4x is negative 5x. 6y minus 3y is going to be 3y. The z's cancel, and then negative 6 plus 7 is 1. These two equations together make up our baby system. So this 11x minus 3y equals 5. 11x minus 3y equal to 5. And this negative 5x plus 3y equal to 1 are our baby system. Can I answer any questions up through this point? I wish I could also take super credit for this method, but this was actually my husband's method. The way I used to teach this was way more confusing. My husband, I was like, man, I don't want to teach these 3x3 systems. Like, I just feel like I confuse people every time I teach it. My husband's like, well, look, you just listen to me for a second. Listen to me how I teach these systems. I'm like, oh, okay, all right, that's a lot better. It's a lot better the way you teach it. Okay. So from here, we're just solving this system. And actually, this one's not bad to solve. Why don't you, real quickly, guys, solve this. I'd like for you to solve this. And tell me what x and y should be as soon as you have an answer. Good job, Zach. So looks like Brooke got number equals number. Is it possible that you tried substitute? Oh, there you go. There you go. Yeah, so this one's kind of nice because they already will cancel out if you add straight down. So if you add straight down on these ones, 11x minus 5x will give you 6x. The y's cancel and you get 6. Me and my variables, yeah. Story of my life. the small things. Math is really great about that. So here, if you divide both sides by 6, because you have 6x equals 6, you'll get x equal to 1. And circling your answers here makes things a lot easier. I've made a system for myself with these ones where X is associated with blue, Y is associated with pink, and then Z is associated with green. And maybe I should have done that when I was like multiplying up here. Made these ones green since we were eliminating Z's. That would have been too smart. No going back. But regardless, make sure you circle. When you get a value, circle it, because we're dealing with 3 different values here, and they're going to get scattered through your page. And it'll make it a lot easier to find them if you circle them. So now that we have x equal to 1, we can use either of these equations to solve for y. It doesn't matter which. I'm going to go ahead and use the second equation because the coefficient on y is positive in that one. So we have -5 times x is 1. And then 3 times y equal to 1. So we have -5 plus 3y equals 1. Add 5 to both sides. 3y is equal to 6. Divide both sides by 3, and you'll get y equal to 2. And just so we're clear, we used that equation. Yeah, we need 3 different ones. So we have 1 and 2. Now it's just 3, but you might be like, oh man, like that's going to be awful to like find that third one, and it isn't. Is Z 3? It is. Z is 3. Z is 3. So you use your eliminator equation, right? You use your eliminator equation to solve for Z. You don't have to. You could use any of these because you have x and y, so you could plug x and y in for the first for any of the equations and solve for Z, but it'll be easiest in the first one. And yes, it is easy as 1, 2, 3, because that's going to be the answer. So let's see. Equation 1, which is our eliminator equation, that was 3x minus 2y plus z equals 2. And again, I'm going to make, even though it says it in the step, I'm going to write it. This is the eliminator equation. So we have that x is 1, y is 2, and my friend z, we don't know. So this will be 3 minus 4, so -1 is equal to z plus 2. Not z plus 2, oh my gosh, what am I doing? Send help. -1 plus z is equal to 2. -1 plus z is equal to 2. Add 1 to both sides, and bam, you got yourself z equal to 3. So our final answer is 1, 2, 3. Now, technically, you should check your work. And if I were doing my own homework, I would check my work at this point because this is a lot of work to go through to put it in and have it be wrong. So if I were doing this on my homework, I would check my answer and make sure it was right. But since we're doing this in class and I want to prioritize us getting through examples rather than us spending time doing algebra, I'm not going to check it. I'm just going to tell you that it's correct. So any questions on this first example before we do another one? Okay. So let's look at this one. So entering the answer in MyLab would be parentheses 1, 2, 3. Yeah, you would enter it exactly like this. Oh, did it freeze? There we go. You should be able to enter it exactly like that. But now that I say that, let me double check that that's how that's what I remember it being. Let me see. They might have it so it says x equals y equals z equals, but I think they want it as an ordered triple. And I can check it real quick like. I think they actually have the parentheses for you. And so you don't even have to put in the parentheses. Preview. Yeah, so when you go on MyLab, it looks like, so first of all, none of them are going to come out to have infinitely many solutions, and none of them are going to come out to be no solution. There's going to be options here. I'll stop sharing here. Stop sharing here, and then I'll share my screen. So you're going to get like 3 options here. It's never going to be these 2. Okay, there's not going to, I did not give you any where there will be infinitely many or no solution. It's always going to be one of these. So you just put X here, Y here, and Z here. And it should be like that for all of them. Yeah. The good news is because none of them come out to be no solution or infinitely many solutions this is just for the 3x3 systems, by the way. With the 2x2 systems, you will get some that are infinite or some that are no solution. But with the 3x3s, part 3 of the homework, you won't have that. So Zach says, I'm stumped looking at this next example. Yes, so I put this in here to look scary, but actually, let me tell you, it's actually misleading. The fact that there's missing pieces actually makes it a tiny bit nicer. But it does make it a little bit, like you have to do a little bit of problem solving to begin with to figure out where you're going with it. So again, this guy's E1, this guy will be E2, this one is E3. We are looking for anybody who has a coefficient of 1. So which equation do we think is going to be our eliminator equation? And which variable are we going to eliminate? I would agree. 1 and Y. Beautiful. Beautiful, beautiful, beautiful. And you're very welcome. All right, so this guy is going to be our eliminator. Eliminator. And we are going to get rid of Y. So we are pairing up E1 and E2, and you just have to go about this sort of, very methodically. You just trust the algorithm, right? We chose E1, step 1 done, sort of. Not all of step 1, but we chose E1. And now we're going to pair E1 up with E1 with 2 and 3. So here we're doing E1 and E2. Next we'll do E1 and E3. And then we'll write it down. So we have 2x plus y is equal to -2. We have 3y minus 5z equal to -12. We want to get rid of y. So we need to multiply this first equation by something. What do we multiply the first equation by in order to get rid of y? -3. Beautiful. We want to make this into -3y. So we are multiplying this top equation here by not 3, but by -3. So multiplying everything by -3, we get -6x minus 3y is equal to +6. For the bottom equation, which we do not need to touch at all, this one is 3y minus 5z equal to -12. Now, if it bothers you that there's nothing here, you could always put in like a +0z. Maybe I should put that in like a different color so that it stands out a little better. You could always put like a +0z. You could put like a 0x here if that makes you feel better. I think it's freezing. Okay, it's kind of moving a little slow. So you could do that if you wanted to. It's like there's no x's there, so it's the same thing as it being a 0. Adding straight down, so -6x, that just comes on down. The y's cancel, and then -5z. 6 minus 12 is -6. There is one of our equations. For our baby system. That's a great question. That's a great, excellent, beautiful question. So what in the world do we do with this frickin' E3? I don't know like how this is lagging. Hold on just a second. Like, is it lagging for you guys too? Like, okay, I'm writing the words HIMYNAMEISAYLA. Lag. That's what I thought. Okay. Yeah, it's lagging pretty bad. Okay, so let's do this. Let's stop broadcasting. Let's go back to the Zoom call. Let's leave the Zoom call. Re-attend the Zoom call. I might need to restart my iPad. We'll find out. Waiting. Waiting, it says. Okay. So we're going to go ahead and restart my iPad. So give me a second. We'll just kind of chill for just a second here. I know that's kind of an inopportune time for it to do this because it's the punchline, but that's okay. Turn back on. At least we're not in like the early 2000s. Well, I don't even, when did iPad first come out? At least we're not in the early stages of technology where lag is way worse. She's starting up. You can do it. All right, let's go to Zoom. A little bit longer. Cannot. Okay. Okay. Meeting. Wow, it is going very slow. I wonder what happened. Why is it being so laggy? I'm very disappointed right now. Just like taking forever to connect and everything. So stay co-host, got it. No audio, share content, screen, start. It is still pretty laggy. Like it's not even letting me. Oh, because my pencil hasn't hooked up. Hold on. All right. Technology. Are you paired? Okay, very laggy. I don't know what else to say here besides that's the best we got. Oh well. So we have 2x plus y equals -2. I think it's catching up a tiny bit. It's just lagging a bit now. For equation 3, though, look at this. 5x plus 3z equals 5. And we're trying to eliminate y's. We don't need to eliminate y's because the y's are already gone. The y's are already gone from him. That was the punchline. Sorry it took so long to get to that punchline. Y already eliminated in E3. Which means that the equation we're going to use is just this equation right here. It already has just x's and z's in it. I know, that was so long for such a... No, it's one of those things where it's like, it's tricky just because it's not what you're expecting, you know? So our baby system altogether is going to have -6x minus 5z equal to -6 and 5x plus 3z equal to 5. Now this elimination is a little bit more complicated. Not bad, not bad. You can either eliminate the x's or you can eliminate the z's. It doesn't matter. If you're going to eliminate x's, you're going to have to multiply the first equation by 5 to make this into a negative 30, and you'd have to multiply the second equation by 6 to make it into a positive 30. Those are a little bigger numbers than just using 5 and 3. So I'm just going to go ahead and use eliminate the z's. So to do that, I am multiplying this first equation by 3. And when I multiply by 3, I get negative 18x minus 15z equal to negative 18. The bottom equation, I am multiplying by 5. And then I have 25x plus 15z equals 25. And notice that the z's cancel, right? So I chose to multiply this one by 3 and this one by 5 because then I would get negative 15z and positive 15z, which would allow them to cancel. So negative 18x plus 25, x is 7x. The z's cancel, and then we get equal to 7. So we get x equal to 1. Can you find both y and z just using x? I love this moment. Just a second, just let me have this moment. I love it when students make such brilliant observations like that. Let me take a sip of water. Yes is the answer to that one. Zach, the answer is 110% yes. So what Zach has noticed here, all right, and this is brilliant. I actually didn't notice this until after I had finished the problem when I was doing it in my own notes. So if you noticed this faster than I did, we have x now. And notice that this first equation and this last equation, we could solve for x, or for y and z without ever finding z using this system here. Because we could use 5x plus 3z equals 5, plug in 1 for x, and then you can solve for z. And then once you have z, and you have, once you have z, that's the third one, but then you could plug 1 into the first equation, and you could solve for y. Brilliant. The answer is yes, absolutely. You don't need to solve for I guess this one had z. You don't need to solve for z in this one. You could solve for z in this guy, and you could solve for y in that one. Brilliant, brilliant, brilliant. So I'm going to go ahead and use this bottom equation right here. To solve for z. So we have 5 times 1 plus 3z equal to 7. Subtracting 5 on both sides, we get 3z equal to 2. And then what happened here? Not equal to 2. What am I doing? Equal to 7. Wait. Give me a sec here. What went wrong here? Oh, that's what went wrong. Like, why is this math not working out? That's because this is supposed to be a 5. I brought down this 7 here, but I was supposed to bring down that 5 there. Rewrite. Nope, you didn't do anything wrong. It was me. It should be equal to 0. And then z is equal to 0. And like I said, you don't actually need 0 to find y. Although you could use it, but we can use just x to find y in that first equation. I'm going to write down this direction just because it allows it to be consistent each time. So solving for y using the eliminator equation was E1, which was the equation 2x plus y equals -2. We know that x is 1. Subtracting 2 on both sides. Be careful here. Be careful here. When you're subtracting the 2 on both sides, it might be easy to think like, oh, this becomes 0 on this side, but really it's -2 minus 2, which is -4. So you get y equal to -4. The other thing you want to be careful about when you're putting your answer together, make sure it's x, y, z. All right, it might be tempting to write your answer as 1, 0, -4, because that's the order you found them in. But it should always be x first, then y, then z. I hear a whiny baby. So are there any questions on that one? Any concerns, questions? All right, excellent. Let's do more because there are more to do. I think I have 2 more. I didn't realize that I'd probably get through all of them. I can always find more though. Don't you worry. There's more systems that exist in the world. All right, so again, choosing our eliminator. We have actually 2 good options for eliminators this time. We're looking for variables whose coefficient is 1 or -1. So if we look here, we could use either equation 2 or equation 3. So this is where either of those options will work. And you can also choose to eliminate x, y, or z because this last equation has so much versatility to it. So you could use either E2 or E3 here as your eliminator equation. I'm going to argue that there's one choice that's better than the others for a really, really small reason. Any guesses on which equation I think should be our eliminator and which variable I want to eliminate? E2 for z. Yes, that is actually identically what I want. Here's my reasoning. You don't have to. You don't have to. But with v, when I go to eliminate in E1 and in E3, notice that because he's already negative, I don't have to multiply by we don't have to make it negative. We don't have to multiply by a negative for things to cancel. So for that teeny tiny reason, I'm going to use E2 and eliminate z. So I'm starting with E2 and E1. So here's where I started to like debate in my notes how to do this because like I like to pair it so that the eliminator is always first. So notice with these guys here, I always do is E1 and E2, E1 and E3. Same thing up here, E1, E2, E1, E3, because E1 was the eliminator. So I want to write it as E2 and E1 and then E2 and E3, but then I debated here, should I put E2 as the first equation? And it doesn't matter. But I think I'll leave E1 as the first equation just because that's how it looks in the system itself. So here, we want this to become a 6z. We want this to become -6z. So I'm going to multiply this bottom equation by 6 because that will give me a -6z. So 2x times 6 is 12x. Y times 6 is 6y. Negative z times 6 is negative 6z, and 2 times 6 is 12. And then I can leave E1 completely alone. And again, being a cheater, pumpkin eater, I'm just gonna just do a little bit of that. Bam. Adding straight down here, we get 15x. 9 plus 6 is also going to be 15y. The z's cancel, and we get equal to 15. Now, here's the thing. We could leave this equation the way it is. All right, 15x plus 15y equals 15. But because there's a 15 in each of these, we could divide the whole thing by 15. We could divide everything by 15, and we'll have a much nicer equation, which will probably help us when we get to the baby system. So I'm going to divide everything by 15 to make it into x plus y equals 1, just because that's a nicer thing to deal with. Yes, and then Brooke had it already. Make it x plus y equals 1. It's exactly what I would suggest doing. It'll make it easier in the final equation for us. And I love that you saw that. Excellent. So now we're going to use E2 and E3. So we have E2 is 2x plus y minus z equal to 2. E3 is x plus y plus z equal to 2. We actually don't need to multiply anything here because the z's will already cancel. And remember, what we're trying to do is eliminate z's. So we can add straight down right away. 2x plus x is 3x. Y plus y is 2y. The z's cancel, and it's equal to 4. That gives us our baby system of x plus y equals 1 and 3x plus 2y equals 4. You could do substitution on this system if you really wanted to. I'm just going to use elimination. I'm going to multiply this first equation by -2 to cancel out those y's. So we get -2x minus 2y equal to -2. And you can see here where it's really nice to have the coefficients be 1, because if we had left it as 15x plus 15y equals 15, we would have, we could have done it, it would have been fine, but we would have had bigger numbers to deal with. All right. So this guy here, I'm going to leave completely alone. We have 3x plus 2y equals 4. Adding straight down, -2x plus 3x is x. The y's cancel. And we are left with x equal to 2. I'm going to use the first equation to solve for y. So we have 2 plus y equals 1. Subtract 2 on both sides, we get y equal to -1. Finally, we use the eliminator to solve for z. So E2, our eliminator, was 2x plus y minus z equal to 2. So we have 2 times 2 plus -1 minus z equal to 2. This will be 4 minus 1, which is 3 minus z equal to 2. Subtract 3 on both sides, we get negative z equals negative 1. And then dividing or multiplying both sides by negative 1 is going to give us z equal to 1. So altogether, x is 2, y is negative 1, and z is 1. Questions on that one? And don't start the next one yet. If you've started the next one, hold on a second because there's a mistake in it. I want to tell you that before anyone's like, I could do this, I could do one. I just want to point out the mistake in the next one before you start it. If there's no questions, then we will move on to the next one. So the mistake here is that this guy right here, that this should be a minus sign. This should be a minus sign. And it makes a difference. Otherwise, you're going to get one of your answers is going to be like 27 divided by 28 as like the answer for the it comes out to everybody has a disgusting fraction as an answer if you don't do it this way. So what do you guys think? Do you want to try one on your own? Do you want to try this one on your own? And yes. Okay. So what I'm going to do is I'm going to go ahead and give like at least a 2-minute head start, and then I'm going to start going through it. At least a 2-minute, maybe a 3-minute head start. We have plenty of time. 3-minute head start. Then you guys can then I will start writing down the answers so you can check your work. It looks like my timer didn't actually start. I thought I could start on it. I'm going to start writing down my answer. Keep working if you're still working. You may have used a different eliminator than me, but it's not going to matter in the end because the answers are all going to be the same answer in the end. But I'm going to start writing down my answer. Keep working if you're working. There shouldn't be fractions. No, this one should come out to be whole numbers. As long as you change this one to a minus sign here, it should come out to be whole numbers. I forgot to add behind the equal sign for the millionth time and got stuck with a fraction for that'll do it. That'll do it. It's always the small things. Just so you know though, on the homework, like nothing is going to come out fractiony. So if you're doing the homework and you get stuck with a fraction, go just check your work for something because you shouldn't be getting stuck with any fractions. not me just going to, I'm just going to double check to make sure I'm 100% correct. Yeah, you won't get stuck with a single fraction in the homework. It's a little too complicated for these 3x3s. I'm okay with the fractions in the 2x2 systems, but in the 3x3s, it's just a little too much. So here, how is it going? If you're comparing your work. All right, that's a good, I like hearing that. I like hearing it. So far, so good. That's excellent. Looking good. All right. And finally, bam. Excellent. Excellent. Brooke, how'd it go? Yay! Excellent. That's perfect then. Excellent. So I guess then we have options here since that's the last one on the worksheet. I can go find another one and we can work through it again, or we can be good 15 minutes early and just call it a day there. I am happy either way. I know there's let's see, 6 people here, so if any of you want to do another one, I'm happy to do another one. We just need to make a decision, or we can just call it class here 15 minutes early. Discuss. The same for me either way. I got time? Sure, let's do another one then. If you want to call it a day, then that is totally fine. I'll just put one more up, and that way, if you want to do another one, never mind. Let's do it. It's like, oh, we're already here. Might as well, right? All right. Let me go ahead and. One down. Try not to make any mistakes while I'm writing it down because that's where things get weird. It's not as pretty as it's not as lined up as one on my worksheet. That's fine. Let's do a tricky one. Ooh, I don't even know if this one's gonna. Well, I feel like this one's a little tricky. You have a lot of options at the very least. We're already here. All right. So go ahead and get started on this one. Give this one a try. long as you guys have it all written down, just keep looking at your work and working, and I'm just going to start going through it so that you can check your work. All right, I am working my way through it. So you will soon have answers to check your work against. If you checked against 2 and you're doing good there, then you can feel pretty good about that answer. The one downside of these, it's hand cramps, for sure, hand cramps. And you know what? I'm gonna actually be a cheater pumpkin eater, and I noticed that all of these are divisible by 3. So I'm gonna go back up here and do that because that'll make a nicer equation. I would rather deal with that one. What did I do here? I think the answer is supposed to come. Hold on. Oh, that's a different system. Okay. This should be right then. So I'm going to go check my work real quick. But here's the answer I got. Here's hoping that's the right one. Got the same. That is very promising. That is incredibly promising. Let's see. If we have two people getting the same thing, I feel like we probably could just say it's good. But I can put this in real quick, just for funsies. -6, 3, 6, 1, 3, -1, 0, 6, -1, -1, and 18. 2, -2, -4. All right, yeah, that's it. That's the whole problem right there. Good job, guys. Excellent work. Excellent, excellent work. Well, then I think that calls it. I mean, it's 4 minutes early, but you guys did great today. I appreciate the work and feeling good about linear equations. That's excellent. That makes me feel so good. Okay, well then we're ending the week strong this week, and we'll come back next week. And it's I'm actually going to change the schedule a bit. I told you guys I was going to do nonlinear equations on Monday. I'm actually just going to take nonlinear nonlinear systems of equations out. I'm just going to take it out. We're going to purely focus all of our efforts on word problems next week. We're not going to try to split our efforts between word problems and another difficult subject. It's not worth it. So it will be word problems next week. I'm going to make it as straightforward as possible. I will be sending out worksheets, but they're just going to have the word problems written down. So if you don't want to print off the worksheets, it's not a big deal. You'll just have to write down the word problem when it comes up on the screen. But that's what I'll be sending out, is worksheets that just have the word problems on them next week. All right, I'm going to stop the recording, but if you have questions, stick around. Otherwise, have a fantastic weekend, and I will see you all on Monday.